Student teaching with Brian Church, even though he is a GA, but we are student teaching for him. 6.1, the indefinite integral. So suppose that we have a marginal cost function. And that marginal cost tells us how it is to manufacture an item, but we want to reconstruct the original cost function. Now we would have to reverse the process of differentiation to go from the derivative to the original function. And you may be thinking, how do you reverse a process? So you would have f of x, and that turns into f prime of x, which is the derivative. But to get there, we need to go back to f of x. We need to get back to here. So we got this little thing here called the integral. Looks like a little s, not an s. So the function inside here, so if you take the integral of f of x, because this reverses the derivative function, you get f of x. These two match. This function inside the integral is called the integrand. The letter x that is being integrated is the variable of integration. So just for a little example, the integral of just x. So how we do this is we have a power rule. So if we have x of n, the power rule, oh, we got a little dx in there. So the integral of this would be x n plus 1, because the derivative, you would lower the exponent, the integral, you up it. You divide that by the new exponent, so the n plus 1. Then you have this c, the constant of integration. Always make sure you have this at the end. So say you just have the integral of x squared. So all it is x, so 2 plus 1 is 3, divided by that 3 plus c. That's all we got, the indefinite integral. Now, handing it over to Mike Robb.
Moving on to some digital problems. Oh, my apology. Let's get that out of the way here. Oh, my bad again. Here, let's get that out of the way. Oh, goodness. Okay, moving on to some digital problems. As shown here in homework section 6.1, everybody's is different because they do switch. For problem number 1, mine is x squared minus 11x. As Alex stated previously, all we're going to do is add 1 and divide by it. As shown here, the subtraction is what separates these two integrals. And what happens is you're going to take this x squared up here. You're going to add 1 to the exponent. That's going to make it x cubed, and then you're going to divide by 3. The same thing happens with negative 11x. It is assumed that the exponent of x is 1 over 1. So when you add 1, it becomes 2, and then you divide by that 2. Moving on to number 2 as well down here. We have 41x to the negative 5th. When you have negative $5 and you add $1, you have negative $4. So you do the same thing here. It is going to be 41x to the negative 4th since you just added 1. The answer ends up being 41 over 4 to the x to the 4th. That is because of simplification, but it could also be shown as 41x to the negative 4 over negative 4. And as you see here, there's also that plus c. That c is the constant, as Alex spoke about earlier. And moving on to Harry with some other problems. Let's get this out of here there. Oh, my goodness.
So suppose we have a simple one here, the integral of x to the negative 8 in respect to d of x. So as you heard a couple times before, what you're going to do is add 1 and divide by it. So adding 1 and dividing by it will be x to the negative 7th over negative 7. That one's pretty simple, but a common mistake people make is forgetting to add plus c, the constant.
Always remember that plus c.
The next one, suppose we're given this as our problem. Now, all we're doing here is we're adding in the integral, and with respect to d of x, as you can see, it's the same problem. And that will give you x to the 4th, because we're adding 1 and dividing by it, over 4. Minus 5x to the 3rd over 3 plus 3x squared over 2 minus 1x, and like I said, add that c, so it's not wrong there. And that will be your final answer here. On to one more problem. So suppose you're given 3x to the 5th minus 6x squared plus x minus 2 in respect to d of x. Simply figuring this one out, you're going to get 1/2 x to the 6th minus 2x cubed plus x squared over 2 minus 2x plus c. And that will be your final answer.